So today we are gonna see about your piston engine car cooling. Okay. So what we are gonna talk about is why do we need cooling in the first place? What is the need for cooling? And then we are gonna talk about how is your any engine of that sake is gonna be cooled. So first is the reason for us having cooling processes. Our engines are called as heat engine. That is, it is gonna turn your heat energy into mechanical energy to do the work. Now, in that wala way, we are gonna lose so much amount of heat as either we are gonna lose it as exhaust gases, we are gonna heat engine components, and all those things is gonna be sent out into the atmosphere. So out of the whole 100% of whatever heat energy we have, we can only convert 25 to 28% of your heat energy as your work done or by the engine. This is called as your thermal efficiency. So the thermal efficiency for any given engine is only up to the range of 25 to 28%. So the remaining 75% is going to be lost either via exhaust gas because your exhaust gas are going to be hot, and at the same time your engine components are going to get heated up because they conduct heat and it is going to get lost. So if in this case, if our components are losing heat, then what can happen is if you are not cooling them down, you can have structural failure because the like it is made up of metals and stuff. They have possibilities of cracking, they have possibilities of melting also if it overheats and all those things. Second one is your oil will, which is like lubricating all those things, is gonna get heated up. That is, it is gonna get overheated, and we are not gonna have effective lubrication, which is gonna reduce your lubricating process. And the higher the temperature it is of your engine, like even before we give spark into your fuel and air fuel mixture, your fuel will start igniting. That is, this is called as pre-ignition, where we don't supply spark into your system. The whole aircraft itself will sorry, the whole engine burns on its own because your engine temperature is very high, where when your fuel and air mixture hits a certain temperature, it is gonna get self-ignited because of the very high temperatures of your cylinders. Then you also have the things like knocking and detonation, where instead of having a steady state of your combustion process, that is, the combustion should start near your spark plugs and slowly gradually move down towards the piston car head. If it doesn't happen this way, if you have detonation, that is, it just goes in one single go, all your fuel burns in one single go because your cylinder is hot. In that case, when your piston is moving up and your pressure and your temperature is increasing, it is going to attain its flash point even faster, which is going to ignite the fuel from so many different directions instead of just one single direction, which is going to burn all the air fuel mixture in one single go. This is called as your detonation, where we are going to have loss of efficiency of your engine. So this is the reason why we have to cool our engines down. Now, cooling our engines down is gonna also have a problem. That is, by mistake or something happens and we excessively cool your engines down, it does more harm than good. What it is gonna do is, again, it is gonna reduce your thermal efficiency because your engine, when it is cold, your lubricating oil and all those things is going to be of high viscosity, where it is going to struggle to move your parts. So again, you're going to lose thermal efficiency. Second is, that is your lubricating friction. It is going to be of greater viscosity, which is going to reduce the frictional horsepower, which is going to lower your brake horsepower. And then third one is vaporization. That is, your whole fuel has to be vaporized, then only we can have effective combustion. If your fuel is not vaporized, it is still in liquid form, in that case it is not going to burn effectively, which again loses your efficiency of your engines. So to maintain a very good engine, we have to have our operating temperatures within neither being very high nor being very low. In that case only we can have a very safe engine and a very effective engine with a whole thermal efficiency of 25 to 28, which is considered to be a really good engine. Now, next thing is we'll talk about how your aircraft are cooled. So we have two types of cooling system. One is called as your liquid cooling system. Second one is called as your air cooling system. So liquid cooling system or air cooling system, what factor does it matter? Like depends on which aircraft or which engine is going to get what type of cooling system is. It is basically the aircraft's car engineer would have decided that whatever cylinder arrangement we are going to have is going to basically dominate the primary factor of which type of cooling system are we going to use. The second one is how big your aircraft is. Like smaller aircrafts like Cessnas and all those things, they don't need like liquid cooling system because they are very open and they are in the very front also. So you can use ram air to cool your aircraft down. And since they are lightweight aircraft, their liquid cooling system, which has some amount of weight penalties, is gonna add up to it, which is not a very good thing for your aircraft. So the designers would have decided that air cooling will do the job or liquid cooling will do the job. So depending on the designers, Kavish, the whole system is working. So both of them are gonna do your same things of cooling your aircraft down, but in two different ways. So first one is your liquid cooling ka system. In your liquid cooling system, what is going to happen is we are going to use a liquid. That is, we are going to mix water and glycol. So glycol being an antifreeze liquid, it is going to be mixed with water and it is going to be circulated through your channels. That is, you're going to have your channels. You have your tank where your coolant liquid is going to be stored. That coolant liquid which is cold is going to be sent to your engines, where you're going to have a tube that is like it's covering your engines like a blanket. And through that through the blanket, the heat is going to be transferred from your engine ka casing into your coolant ka liquid. So the whole engine is now going to be very, like, the whole coolant is now hot, and then that hot goes into your thermostat. This thermostat, what it does is it measures the temperature of what is your coolant ka temperature. Because if our coolant ka temperature is high, that means we have less coolant in our system and our engine is overheating. If your coolant ka temperature is very low, that means we have more coolant in our air and we are overcooling our engines. So it has to be within the right operating temperatures. That means we can get our job done. Now this, after this thermostat, it is going to pass through into your radiator. Now radiator is going to be like a net curves and stuff. That is, it is going to run left and right, where your whole hot coolant liquid is going to run through it. When your propeller spins, your aircraft moving forward and all, that ram air, whatever is being sent into the engine bay area, is gonna cool this down. That is, it is gonna cool your coolant oil ka temperature down. And then again it goes to your thermostat, and then it goes into the tank again, being a cold liquid. Now what advantage does this have over your air cooled system is the way the effectiveness of your cooling is really good, because your heat carries away all the temperature and you can have a very effective cooling of your aircraft car engines down. But what comes as a penalty is the whole maintenance cost. That is, you have to maintain your radiators properly. If even a small stone hits one line of your radiator, you might be ending up in changing your radiator. Or if your thermostat breaks down, you have to buy a new thermostat. The whole header tank can be changed. You'll have pumps that is gonna keep on pumping your coolant oil throughout your entire line. Your pumps can fail. So all these things can happen, which needs maintenance. So it is going to be little costly in your maintenance part. Second one is, since you have so many components of your cooling system, our weight also increases. So we cannot, if an aircraft cannot afford to be heavier, we cannot use a liquid cooling system. Next is your air cooling system, where we only use the airstream that comes into the aircraft either through your propeller ka slipstream or the forward motion of your aircraft, called as your ram air. Now what this is going to do is your cold air is going to start coming through your air intake, and it is going to go and it is going to touch your baffles. So around this gray color part is your cylinders, and around it you have a tiny area and you'll have a small gap in it. So what these baffles does is it ensures that whatever air that comes in makes a turn and goes into the baffle ka space. That is the space between your baffle ka walls to your engine ka cylinder. So when it comes in contact with that particular engine cylinder, it is gonna cool it down. That is, the heat is gonna be transferred to your air, and that air is gonna leak through this and it will exit via your cowl flaps. So because of this particular thing, we can use our air cooled engines. Now, what we can do in case, like, let's say we are overcooling our cylinders or something like that, we can close the cowl flaps. In that case, your air is not gonna go exit out. It is gonna be roaming inside your engine cowling, which is gonna increase the temperature of the engine. In some cases, let's say your engine temperature is overheating, you can open the coil flaps furthermore or fully open, where all the air is gonna go out, and it helps us in effective cooling of your engines. So this is your adjustable flow of your air cooling ka system. Now, in summary, if you say which one is more effective than which one, it is like neither of them are like very, like both of them are very effective. That is, both of them is designed in a way that they are gonna cool your aircraft cut down. But depending upon the aircraft ka power requirement and how it is operating, what are the conditions and all those things, it is going to change ki which one should they use, either a air cooling system or a liquid cooling system. Both has their own pros and cons, which they will they'll see which one has more weightage to it, and they'll decide ki whether should they go with your air cooling system or your liquid cooling system. Now, this is the whole table which talks about your whole thing about your liquid cooling to your air cooling. So, your cooling medium in a liquid cooling is water glycol mixture, whereas air cooling is just normal air. Your heat transfer method is going to be fluid is circulating through a passage, goes into the radiator, where RAM air meets the radiator, like coolant liquid inside the radiator. The RAM air takes away the heat energy from the coolant liquid, then the coolant liquid goes into your tank again. Whereas in your air cooling system, you're going to have air only, which is going to go through your internal baffles and it is going to touch the fins of your engine car cylinders. And then you will have effective cooling. Then you also have flow control. That is, you can use pumps and thermostat to measure the temperature. If your engine is way cooler, you can turn off your pumps where your coolant is not going to flow through it, which will help us in gaining the temperature back. If you are using a air cooling system, you can open or close your coil flaps, which is going to help us in either increasing the temperature, or if it's very high of a temperature, we can decrease it. The main advantage of liquid cooling over your air cooling is that you can have a very precise temperature control. That is, whatever temperature you want to control, that is how much coolant liquid will be flowing through your pipe. So it helps us in having a very good temperature control. But when you talk about air cooling, the air cooling ka best part is the simplicity, because we don't have any amount of components that is there in your aircraft, which reduces our cost by a lot of amount. That is, let it be the installation cost or let it be your maintenance cost, both of them are going to be decreased by a larger extent. It is going to be lightweight because we don't have any component at all, and there is no maintenance at all. It is not even less maintenance, it's like literally no maintenance. Now, your where all can you find liquid cooling systems is you can find it in high powered aircrafts, complex engines, and all those things. Whereas your air cooling system is all small aircrafts and with radial engines and all those things are going to have your air cooling system. Then we are going to talk about what are the factors governing the efficiency of an air cooling system. So first one that we'll talk about is your air temperature. That is the what is the ambient air temperature that is outside, which is going to help us, which is going to affect the amount of air cooling that you're going to have in your aircraft. So if you are flying in a hot summer day, that means we have to have greater amount of cooling, where because even the ambient air is hot. So when it touches your aircraft engine, it is not going to cool effectively down. So your engine is going to be slightly hotter when compared to a winter day. The problem with winter day is you're going to have a temperature which is very less. So you will overcool your engines. So depending upon what type of day we have, we can either open or close our cowl flaps or even your pumps and all those things, operate your pumps accordingly, which will help us in getting more like control over your temperature. So first one is your air temperature that is going to affect it. Does it depends upon whether we are flying in a hot summer day or are we flying in a cold winter night. Second one is your speed of your airflow. So if your speed of your airflow is what is going to determine how efficient your air cooling system is, because more airflow into your engines, better cooling we are going to have. But at the same time, if you have way more amount of airflow into your engines, we are going to overcool your engine. So you have to be taking care of how much amount of air goes into your system. Now we also have a problem, that is, if we are on the ground with powers like more than ideal conditions, we were been running, we were doing some checks and all those things. In that case, you are not going to have effective amount of airflow that goes into your engine cowlings. So this is going to cause overheating of your engine car cylinders, which has problems with it. So we have to make sure that on the ground your aircraft is idle and we are not holding there for very long, so that your engine is going to overheat without any amount of airflow going into your engine car bay. Then you have your engine construction, how it is constructed, what type of components is your engine made up of. So if your engine made up of like different components which heats quickly, your engine temperature is going to go up again. So depending upon how it is made, what type of material. If you have like a four-cylinder engine, inline four-cylinder engine, in that case, or a V4 cylinder engine, what is going to happen is the front engine will get more amount of airflow, whereas the rear engines will not get any airflow. So the rear engine will be shadowed by the front engine. This is going to cause the rear engine temperature to be higher than the front engine's temperature. So your engine construction also matters. If you're using such type of engines, that V engine, W engine, whatever we are using, if one engine is going to be the other, we have to accompany some other ways of cooling the engine down, like we can use an air cooled system. Next is about your cooling fins. So cooling fins, when we talked about in the first chapter, that is basically we are going to have like small surface area protruding out of your engine cars cylinders. What this does is it increases the surface area of your engine where you can have effective contact of your air. So your air is going to come in contact with the greater part of your engine rather than not at all having a fin. But having a very larger fin area means your engine is gonna overcool it. So to not let it overcool, we have to make it, design it in such a way that it is not very big nor very small, where you're not got all gonna have effective cooling. It has to be made in such a way that they are thin and they have increased in surface area. So you'll have a lot of protruding areas, which is gonna help us in extra like cooling your aircraft car engine down. And you'll also have like so many more amount of fins, that is you'll have a lot of greater extended fins in area wherever you have local hotspots. Local hotspots is wherever they are feeling that that particular area alone your temperature will be slightly higher. We put fins which is slightly greater in size. Why? Because that areas are prone to local hotspots which can cause either preheat pre ignition, or you can have detonation also. So to not let this happen, we are gonna use small, like little larger amount of fins in those particular areas alone, or maybe more in number of fins in those particular areas. Then the last thing that affects your air cooling cut temperature is your cowlings, how your cowl flaps and grills are opened or closed. So if your cowlings and cowl flaps are open, in that case, there is no disturbances to your relative airflow. Everything is fine. You're gonna have very good cooling effect. But if in the case any kind of disturbance that happens inside your baffle or inside your cowling, you have something which is triggering a turbulent airflow, which is not allowing your air to go through your baffles and not go outside your engine, your air is gonna get stuck there. If your air gets stuck there, which is already hot, if more air comes in, it is going to get hotter and hotter and hotter, where you're going to have more amount of problems with it. So we have to make sure that there is like literally free airflow that can go through your coil flaps, baffles, and all those things, and there is nothing that is obscuring the airflow movement. If there is something that is there, then it will create a problem of overheating your engine. So you have to make sure that your coil flaps and your grills are open. They are clear of debris, dirt, or whatever. At the same time, your baffle lines are all clear and they have very smooth airflow so that air can come in and exit out without creating any turbulence. But this has a problem, that is, since your front part is open, air tends to come in, get settled there, and then only get outside. So there is going to be some amount of drag created, but considering all the other pro factors of your air cooling system, we still go with your air cooling system. Now we are going to talk about your cylinder head temperature gauge, also called as your CHT. So what is your cylinder head temperature gauge does is it allows the pilots to monitor what is the engine cut temperature, what is the engine head cut temperature in real time. So whatever temperature it shows, it is going to be the temperature that your engine is actually working in. Now, how are we going to measure this? We are going to use a thermocouple. So the job of a thermocouple is to convert your temperature measurement into electrical voltage. Once it is converted into electrical voltage, it is going to be given from that electrical sensor through wires into your aircraft car instrument gauge. So that instrument gauge, with respect to how much amount of current is produced, is going to point your values, either placarded as degree Celsius or degree Kelvins or degree Fahrenheit, whichever we are going to use. Now, where are we going to put this thermocouples? Not every single engine is going to have them. The backmost part of your engine, that is, if you have four cylinders, let's say V4 engine, the backmost part of your engine is going to have this thermocouple because that is the hottest engine that there is. The front engine, because of the ram air effect and all those things, will cool down faster. Whereas the back part is not going to be cooled down because the front cylinder is shadowing your back cylinder. So we are going to keep your thermocouple at the rear cylinder and we are going to pick up your pick up your temperature, which is converted into voltage, and then we are going to have your readings. So this is called as a moving coil galvanometer, which is going to give us what is the exact temperature that it reads. Now, what are the key essential points of your cylinder head temperature gauges? we have to maintain a very good cylinder head temperature. If your temperature is way higher or way lower, we are either overcooling or we are undercooling your engine, which can create problems for your engine ka health. So it helps us in monitoring your engine's ka health. It also prevents your aircraft from either overheating or overcooling your aircraft. Next is we'll talk about your uh, hmm, okay, I put it two times. Fine. So next is we'll talk about your operational procedures. That is how are we gonna fly your aircraft not by not overcooling or not overheating your aircraft. So what are we gonna do is we can like first we'll talk about cooling your aircraft during climbing and descending. So whenever your aircraft is air cooled engine, we are only bothered about air cooling because liquid cooling really doesn't matter because liquid does the job of cooling your aircraft car engine. So regardless of are you doing a VX or a VY, your aircraft will always be cooled at the same rate. But air cooling, since it is primarily dependent upon how much amount of airflow we are gonna get, it has to be cooled at the correct rate. So if you are climbing at a VX ka climb, your angle of attack is going to be very, very high, which is not going to allow a lot of airflow that flows into your intake, which is going to cool your aircraft down. And since you are at a very high angle of attack, your aircraft ka engine is at full power and it is doing a lot of work in climbing your aircraft. So this is going to create a lot of heat. So we have a lot of heat that is being generated by your aircraft. At the same time, we don't have enough amount of relative airflow that goes into your engine to cool it down. So this is going to create problem of overheating. So what is the best procedure to do it is whenever we are in a climb, the first part should be a VX climb, then we can transition to the VY climb. But the more general rule is always climb out at VY, which helps us in effective cooling of your engines. At the same time, whenever we are descending, in a descent, when like basically if you are in idle power and you're descending and you want to do a rapid descent, we always do a dive. That is, we are going to come nose down first and we are going to have a lot of airflow that goes into your engine. In that case, we are going to shock cool because we don't have power. We are in idle condition. The heat generated by your engine is very, very less, and the amount of airflow that goes into your engine is going to be very, very high. This creates a problem of thermal shock which can damage your engines again. So to not let this happen, we are not going to descend at a very faster rate at idle powers. We have to descend gradually at slower rates. And whenever we feel like our engine temperature is cooling way below down, we have to add power level off or like do something where we can increase the temperature again. Other things that we can do is we can close the cowl flaps and we can start our descent. So closing your flaps down is not going to allow all the airflow to pass through it, where it is going to get stuck inside your engine cooling. So your engine temperature will always be higher and it doesn't shock cool our aircraft. So this is the whole process of how are we going to fly whenever your aircraft is climbing or descending with respect to your cooling. So always do a VY. If really necessary, we can do the first part as VX and the second part as VY climb. Next is we have cooling methods. So if you're like correct in your aircraft, it is having complex aircrafts and all those things will have cowl flaps, grills and all, which pilots can operate based on like you can either open it or close it. Like Asana cars and all have a separate lever to for opening and closing your cowl flaps. So in that case, we can either increase the amount of temperature that your engine needs, or we can also decrease it by opening it. But in a very like small flights and all those things, in that case we are not going to have these type of control mechanisms where we have to control our cooling by your airspeed only. So if your engine is getting cold faster, reduce your airflow, get the engines hot again, add power and get your engines hot again. If you are like flying an aircraft which is like overheating, then start flying faster, either put your nose down to get more amount of airflow into your cowlings, which is gonna effectively cool your engines down. So these are the ways where you can, if you are flying a complex aircraft to your normal aircraft, you can cool your engines down. Then the last thing is your engine operating practices and your cooling systems. So whenever your aircraft is on the ground, try not using full powers or high powers so that your engine doesn't get hotter, because in on the ground we don't have effective amount of airflow. Whatever airflow that goes into your engines, it's always because of your propeller ka slipstream. Other than that, we won't have any amount of airflow going into your engines. So due to this particular reason, we cannot use more powers on when your aircraft is on the ground. Second is you have to make sure that we have sufficient amount of engine oil that is there in our aircraft. So lesser the engine oil, because engine oil ka one of the job is to cool your engines down. So the primary job of engine oil is to lubricate it. The secondary job is cooling, cleaning, and all those things, in which it plays a vital role in cooling your internal parts of your engine. So air and liquid is gonna cool it from the external. Your lubricating oil is gonna cool it from the internal, so that your engine temperature is a little lesser. Then we always have to maintain mixture strength. That is, your mixture strength will be subject, like you can change your mixture strength by checking your cylinder head temperatures. So whenever your mixture is leaned to a way greater extent, it causes your CH3 temperature to rise. Why? Because your fuel has nitrogen atoms in it. This nitrogen atoms helps us in cooling our aircraft ka system down, aircraft ka engine down. So if you're flying at a way leaner mixture or exactly at that mixture which is sufficient, you're gonna burn all the nitrogen atoms, which is not gonna effectively cool. So always flying at a slightly richer mixture than whatever is necessary helps us in cooling our aircraft down. So your fuel also helps us in cooling your aircraft down in this sake. Then whenever your aircraft is like before shutting down your aircraft, always make sure that your engine runs like at least 1000 to 1200 rpms before you're preventing your shutdown, so that it doesn't rapidly cool or it doesn't unevenly cool your engine, which is going to cause a little cracks and all, because your engine were operating at a very high temperature. Now they are going to go to a very low temperature. So in that case, this expansion and contraction is going to create some amount of cracks in your cylinders, which can be catastrophic. As time passes by, they are going to break and you're going to have an engine failure. Now, talking about your aero diesel engines, that is, we are going to use diesel engines also, which is under testing and all those things. They use both your liquid or your liquid air cooling to provide more effective amount of cooling, because diesel engines are very high or very hot engines when compared to your petrol engines or 100 gasoline engines. So in order for your diesel engines to be cooled down, we are going to use both ways of cooling. We are going to use air also, at the same time your liquid also, which does the job of effectively cooling your engine temperature, even though they are going to have at a very high. But what this increases is, it increases your cost and also your weight penalties of your engine car system. So this is the only problem with your aero diesel car engines.